Hello, this is question 17 on your AQA paper from June 2024. It's paper 1. And you have a function f is defined by this. So fx is the modulus of x plus 1 for any real number. Function g is defined by ln of x with the greatest possible domain. And using set notation, we have to state the range of f. This one, the range of this one. Range. So remember, if I represent magnitude or modulus of x, so this is y equals x, when I do the modulus or magnitude, any negative part becomes positive, so my function is doing this and this. That would be magnitude of x, and if I have plus 1, I am moving it vertically by 1, so my function really is this one. So I move that all up 1, yeah, and this is 1. The range is the output. So for any value of x, so I'm going here with any value of x, the y is going to go from 1 all to the infinity. So I'm going to have values of output from 1, including 1, all to the infinity. Yeah. So my range is going to be, and remember we are going to write the range with y, or if you prefer with fx, but not with x, is going to be greater or equal than 1. They say to write it in set notation, so the only thing I'm going to do is to just write y colon at the front and the curly brackets. Yeah, and if you prefer instead of y, you can use fx, but if you use x, sometimes you will lose the marks. Then state the domain of g. G is this one, and it says the greatest possible domain. Remember, learn is not defined for 0 or negative numbers. And again, if you want, you can think about the graph. So the graph of learn, remember, is this one. It has an asymptote here. So it's not defined for 0 or for any negative numbers. So the domain is above 0. So the domain, and I'm going to use x because it's domain, is going to be greater than 0, for example, with x, any real number. Yeah? Then they don't say use set notation, you can or not. So if you want to use set notation, you just write x colon at the front and the curly brackets. But they are not asking, so it doesn't matter. Composite function h is given by g of x for any real numbers. Write an expression for h of x in terms of x. So remember, when we do a composite function, the only thing that we do is to apply, so hx is g of f, yeah? We are going to apply f first, so always the closest to the x, and then we are going to apply that to this value here. So this is my new input. Fx was the absolute value, so is going to be magnitude of x plus 1. And now I'm going to apply g, and g is ln x. So it's just ln of x plus 1. Yeah, that's your function h. Then determine if h has an inverse, and it will be for any value of x. Yeah, so this would be for any real numbers if you want to add that. And remember, to have an inverse, this function needs to be 1 to 1, and it's not, because when I have a positive value and the same but negative value, this is becoming the same answer. Yeah, so for example, and that's what you can say, the function so it has no inverse, it doesn't have inverse, has inverse because it's not 1 to 1, yeah, because it's not 1 to 1. And how do you justify that? So you, for example, do h of minus 2 and h of 2, and you will see that it's the same. Yeah. So h of minus 2 is modulus of minus 2 is 2 plus 1, 3 is ln 3. And when you do h of 2, modulus of 2 is 2 plus 1, 3 is ln 3. Yeah, so is many to 1. Yeah, is many to 1. so it has no inverse. Yeah, and that's the only justification. If it's not 1 to 1, it won't have inverse. Every time it has no, it's not 1 to 1, it won't have inverse. Yeah, and that's all.